Good day viewers, today we are going to Newton laws of cooling. Newton laws of cooling. So what is Newton law of cooling? Newton laws of cooling state that the time rate of change of temperature of body is proportional to the temperature difference between the body and the surrounding medium. The time rate of change of what? Of the temperature of body is proportionally to the what? To the temperature difference between the body and the surrounding medium. Let's donate T as the temperature of the body and Tm as a what? Temperature of the surrounding. Let's donate this one as the temperature of the body and Tm should be donated as what? Temperature of surrounding. So the time rate of change of the temperature of the body, that is what? The T all over the T, and this is the time rate of change of temperature. Change in temperature and change of what? Change in temperature of the body is what? The T all over the T. So how can we now make this one? How can we now input this as an equation? How can we vary it directly to the surrounding? So this is what? This is denoted as what? Temperature of the body, temperature of the surrounding, the time rate of change of the body. So according to the Newton's law of cooling, so let's say the time rate of change of temperature of the body, is directly proportional, that is varies proportional to the temperature difference between the body and its surrounding. That is, the difference is what? The subtraction of what? The temperature of body from what? Surrounding. In case that we have T minus Tm. T minus Tm, that is the temperature between what? The difference between temperature of the body and what? The surrounding. So from here, we now have the T all over the T is equal to what? K T minus Tm. So from here now, in Newton's law of cooling, we have something like this minus K T minus Tm. This implies means that our T must be greater than Tm. If our T is greater than Tm, our K will be negative here. But if this condition does not hold, if T is less than what? Tm, we have a constant K. But in Newton's laws of cooling, our T must be what? Must be greater than Tm. So we now have a negative constant of K. So how can we solve this? How can we now solve this? So if you have anything like this in differential equation, how can we solve this? This is a what? We can use variable separation to solve this. We separate T from the changes in T, capital letter and small letter. So from here we can have something like this. Remember that this is what? T, the T all over the T is equal to minus K T minus Tm. So because of the board is short, I have to rub it off. So do it. So we have dt is equal to minus K T minus Tm. So from here, using variable separable, we can cross multiply. We have dt is equal to minus K T minus Tm all over dt. Using variable separation or separable. So from here, we have dt is equal to minus K T minus Tm. We can divide both sides by T minus Tm so that our K will have dt, our dt we have this, because we are using variable separable. It means T will take T minus Tm. When this one is a constant, we take a what? Dt. So we now have dt is equal to minus K T minus Tm all over T minus Tm all over T minus Tm. So this is a what? Variable separable. So this will be able to cancel this. It means we have separated this. So from here, I can write this one as all over 1 all over T minus Tm dt is equal to minus K dt. So since we have separated the variable, what is the next? We have to what? Integrate both sides. Integration of both sides. If you integrate both sides, what are we going to get? So let's integrate both sides. If you integrate both sides, what are we going to get? You get integration sign 1 all over T minus Tm dt is equal to what? Integration sign minus K dt. Remember that when you have a constant, this is standard integral. If you are integrating a standard integral, we have to put our exponential to it. If you differentiate the denominator, we are going to get 1 minus 0. We are going to get 1 over 1. So 1 over 1 will multiply this. We now add exponential to it. So as our standard integral. So if you integrate this, we are going to get ln t minus tn. So we have exponential ln, or natural log ln t minus tn is equal to, if you are integrating with a constant, we have to add this to it. Remember, if you want to integrate x, if you want to integrate 5, we are going to have what? We are going to, respect to x, we have 5x. If you want to integrate x, we have what? X is power 1 plus 1 all over 1 plus 1. So this is a constant. If you are integrating, we have to apply the respect to what we are integrating to it. So this t, we have to what? It will be what? Kt. So if you integrate minus k, we have what? Minus kt plus c as a constant. In integration, after we have integrated, we have to add our constant to it. So what are we going to do here? We want to make t the subject of this formula. So you have to make this one. You have to take this one to here. So we want to make t as a subject. So what can we do here? So remember that t minus tm that we have here, you can take exponential of both sides. Taking the exponential of both sides. If you take exponential of this side, this will be able to cut, to cancel, so that we now have t minus tm. So if you're taking exponential on both sides, taking exponential on both sides, exponential on both sides. If you take exponential, we now have something like this: exponential ln t minus tm is equal to exponential minus k. Exponential will raise to power plus exponential c. So from here now, what are we going to get? Since we have exponential ln, so we have exponential ln t minus tm equal to exponential minus kt. So remember, we can write this one as this, loss of indices, this as this. So from here, you can now what? You can cut exponential and ln will cut each other according to the law. So we now have t minus tm is equal to, whenever we have something like this, we have what? We have to add what? In exponential, in loss of indices, what are we going to do? When you have a times, we change the word plus. So since this one they are the same, we take it at once. Exponential minus kt plus c. So from here, you can make t as the subject of the formula. So this is t. Let's take this one to here. We have exponential minus kt plus c. So it's equal to what? Plus tn. So whenever we have anything like this as a constant, you have to come first to the before the exponential, so that our constant will be what? We have a value here. So we now have t is equal to c exponential minus kt plus tn. In this case, our tm can come first as a surrounding medium. So we now have t is equal to what? Tn plus c exponential minus kt. Either this or this is also the same. We just prove the formula for Newton laws of cooling. And if you are given any question on Newton laws of cooling, to find the temperature of a body, maybe using surrounding, it can be the temperature of the surrounding, temperature of the body, it can even the time. We apply this formula. We apply this formula. So that is the temperature of the body is equal to the temperature of the surrounding plus C is a constant of the integration. Exponential raised to power what? Minus kt. Exponential raised to power minus kt. So in our next video, I'll be doing some problem on Newton's law of cooling. Thanks for watching.